Now let's work some problems. First, we're going to start with the given information right here, and we will always have these 5 factors: the stock price, the exercise or strike price, the risk-free rate, the time to maturity. I'll put that in months. That's important. Sigma is the volatility. This is a non-dividend paying stock, so we just worry about these 5 factors. Step number 1, we need to find the U, D, P, and A. Step number 2, we need to build out the stock tree. And then step number 3, we need to find the value of the call or the value of the put, depending on which one you've been asked for. Alright, so U is the up jump. So I need to find the amount that I expect the stock to go up every time, and that's going to be E to the sigma square root of delta T. And I don't want you to memorize this as much as understand what's going on. I need to have some estimate of the volatility. The volatility is, how far it's going to go up, how far it's going to go down, and some estimate of the time frame that I'm looking at. Okay, so in this case, sigma is 0.2, so E to the 0.2. Delta T, what's that? So let me go ahead and put the square root in here. I have 12 months to maturity, and I'm going to do this in 3 steps. So each step should be 4 months, right? From time 0 to time 4 months, time 8 months, time 12 months. So that's 4 divided by 12, because I quote my volatility and I quote my interest rate in annual terms. So this is going to come out to be 1.1224. Of course, there'll be some rounding, but you can deal with that later on when you look at the spreadsheet. D is going to be E to the minus sigma square root of delta T, which is easiest to say D is equal to 1 over U. So now you just hit the 1 over X button on your calculator, and you see that D is equal to 0.8909. What about P? P is a risk, or I really should call it rho, lowercase rho. It's the risk neutral probability of an up jump. And the way I'll do that is E, and this doesn't really make a lot of intuitive sense when you look at it. You can't say, oh, no wonder that's what P is. It's algebraic derivation. If I didn't do it in another video, I can do it some other time. But these are the risk neutral probabilities. So E to the 0.2, and then delta T, 4 over 12, which of course is 1/3, minus D, which is 0.8909, over U minus D, 1.12224 minus 0.8909, and that gives me the probability of an up jump there, 0.54%. A is a little different. A is a discount factor, and I just do this because I have to calculate this discount factor so many times, and we'll see that later on. It's easiest if I say E is equal to minus E to the R delta T, which is E to the minus 0.05 times 4 over 12, which is 0.9835. Okay, so now that we've done that, let's go ahead and go to step 2. So let me get this stuff out of the way. And remember, step 2 here is building out the stock pricing tree. And so what I need to do, and I'll attempt to draw this out. This may be the best way to do it. You start here with a price of 40, and this is of course time 0. And then here's time 1, that 44.90. Where does that come from? Well, the 44.90 is just 40 times 1.1224. I think this would be the easiest way. Just do this. Here's step 2. So where does this 44.90 come from? We're saying the stock went up, and it went up by 1.1224, so that's my 44.90. It could go up again, so 44.90 times 1.224 would be the 50.39, and it could go up again. The 50.39 times 1.224 is equal to the 56.56. Now the way you want to do this in your calculator, do this in one big calculation. Just do 40 times 1.1224, write down the 4490 here, and so you don't have to worry about the rounding. Just take the solution from here, multiply by 1.224 again, write it down, and continue like that. And then the next thing to do this the quickest possible way, you're going down. That 3564 is equal to 40 times D, which is 0.8909. And then you get that answer, right down, multiply by 0.8909 again, multiply by 0.8909 again, and there you go. I know when I come back to here, I'm coming back to 40, because the tree is going to recombine. It goes up and back down, up and back down, wind up in the same spot. So I don't even have to do this calculation. I know that's 40. Now that's all that's left. Just take the 3175, multiply by U, or the 40 and multiply by D, either one. Take this 40, multiply by U, or take this 5039 and multiply by D, and now I have the stock pricing tree. Okay, so most of that is, kind of irritating algebra that you need to do. It's nothing complex. Just remember, you're going up or you're going down. And here, this next step is also relatively easy. You just have to remember the logic and the methodology. I know for a call, the payoff of the call is the max of 0 and ST minus X. So if you could tell me today what the stock price is going to be in a year, I don't have to do any of this stuff. What I've come up with is these are the 4 possible stock prices that will occur in a year. Oversimplified, yes. Typically the steps are not going to be 3, they're going to be 30, but it's the same procedure, so don't worry about adding that level of realism. So what I need to do is, at expiration, which is this time right here, see when does this thing pay off. So here, this will be the max of 0, or 56.56 minus the strike price of 42, which is 14.56. This 290 is the max of 0 and 44.90 minus 42. And then these two are 0 because they are the max of 0 and, in this case, 3564 minus 42, which is negative, and then the max of 0 and 2829 minus 42, which is negative. Okay, so now that I have that, I have the last step in the tree, and now I just need to work backwards. So now it's just a coin flip. At each time, if I'm sitting right here, so what's happened, the stock has gone up and it's gone up again. So if I'm in this spot, I know the stock either goes up again or it goes down. If it goes up, it's worth $14.56. Down, it's worth $2.90, right? So the value of this option, let's call it lowercase c, since it's a call, the value of the call is equal to e to the minus r delta t. Why is that? It's because that's the discount factor. Remember, present value is equal to future value times e to the minus rt. So that's where that comes from. And I'm saying, well, what happens if it goes up? There's a probability it goes up, and it pays, this would be c. At this point, this is cu because it goes up, that's c down. 1 minus p cd. So look in general what this is saying. Inside the brackets is my expected payoff, and then here's my discount factor because this expected payoff takes place in 3 years. So c is equal to 0.09835. That's why I did this A. Do it once, write it down. The probability, think of this as a coin flip. The probability of getting heads is 0.05438. If I get heads and it goes up, then it's worth 14.56. Plus, if it goes down, the probability of going down is 0.4562, and it would be worth $2.90. So this equals the 909. We do that another time here. The call, so this actually, this would be, you could call this call up, up, so CUU. You could call this call up, down, so CUD is equal to the discount factor. The probabilities don't change. They don't write them the same way, 5438 times fill in the blank plus 0.4562 times fill in the blank. So I'm doing the same procedure every time. All I'm doing, no matter where I am in this tree, it's either the stock price is either going to go up or down, and it's going to give me a value to call at that particular node in the tree. So when I'm right here, at this point, up is now $2.90, down is 0. Does that make sense? See, if we went to 909, which is going up twice, then up is 1456, down is 290. But if we went down and up, or up and down, now up is 290, down is 0. So call DD is equal to, so if I go down and down, it's going to be 0. I don't have to go through, technically it's discount the probability of getting 0 or getting 0, right? So that's where that comes from. Now let me clear this off, take it back another step here. Let's do these two. So this would be call up right here, 0.9835 times, if it goes up, the probability of going up is 0.5438 times, you would get 909 plus 0.4562 times $1.55. And now these, again, remember, these are European call, European put. This brings me back to the 555. And if I was doing the 83 cents, all it would change is this would be $1.55 and this would be 0. To get to this point right here, this 334, this is going to be 555 going up, and going down is 83 cents. And this would be the price today, so the call price is $3.34. So I'm willing to pay $3.34 today to buy this option, and the option is the bet that it's going to go, that the stock price is going to go up, and it's going to go up to 56.56 or 44.90 for me to have a payoff. I build out the possibilities of the stock. That's the stock tree. Then I go backwards through the tree. Here are the payoffs. Given those payoffs, now this is just a game. At this point, heads, tails. At this point, heads, tails. Work back through the tree. Okay, so let's look at the European put. European put is going to work much the same way, except the payoff is the max of 0 and X minus ST. So in this case, I need the stock price. Let me go ahead and put in max of 0 or 42 minus ST. When will this be positive? This is only going to be positive when the stock price is below 42, which is only in these two cases. So this is 42 minus 35.64. This is 42 minus 28.29. Now that I have this, I have my possible payoffs. It works exactly like the call. There's no difference, because now I'm just playing a game, and the game looks like this. The value of the put is equal to the discounted value, e to the minus r delta t, times the probability that it goes up. I'm going to use this terminology right here, because we have probability and put, with both start with P, so it gets a little confusing. Just use F, because that's terminology people use. The probability if you go up, plus 1 minus probability of going down. So in the brackets is expected payoff. Outside here it's a discount factor. So the discount factor 9835, probability 0.5438 times something plus going down 0.5462 times whatever it is if you go down. So let's start right here. So if I go up, it's 636. If I go down, it's 1371. Alright, so that gives me a put price of 955. So in other words, if the stock goes down and down again, that put should sell for 955. If I'm at this point on the tree, so the stock price after 8 months is back to 40, it goes up, it's worth 0. If the stock price were to go down, it would get a payoff of $6.36. So that bet is worth $2.85 today. So another example right here means the stock price has gone down. It's currently 4 months in the future, $35.64. If it goes up, it's worth $2.85. If it goes down, it's worth $9.55. Do the math, this will be $5.81. The last step here, the $3.29, that's worth the put option is worth today. That's going to be the discount factor, 9835, times the probability that the stock goes up, which I don't want to happen, and the put would be worth $1.28, plus the probability the stock goes down, which is what I want to happen, times what it would be worth if it did, the $5.81. So that's the value of my put today. Alright, so what I want you to do is repeat this, change that to 25%.